All right, welcome everyone to Democratizing Data Access with Secure Analysis Environments. Now, before we get started for today, if everyone could just make sure that they have downloaded the AWS Summit app, you can provide our speakers feedback on that and all of them would really appreciate it. Now, to introduce this session, this is a level 200 session, so get ready to hear on how New South Wales Health is making data access faster and safer using AWS to unlock insights while keeping sensitive information secure. It's my pleasure to welcome to the stage Orn Iftikhar.
Hi everyone, thanks for joining us today, those who are able to make it in person and those on the live stream. Great to have you here. You are an enterprise business owner or technologist who wants to transform how you operate as an organization and service your customers by being more data-driven. You want to enable access to business-critical and sensitive data for your data teams to drive innovation and insights. Data teams, in turn, want access to this data and the ability to collaborate on this data in a safe environment. Together, you want to do amazing things with your data, but you're unable to operate at the velocity and scale that you require while ensuring data security and governance. Well, we're here to tell you that there's a better way. And today, you'll hear from a customer on how they're using the power of AWS to solve for challenges similar to yours. A quick look at the agenda, what we'll cover today. We'll talk about how data is a strategic asset for every industry. And then I'll invite Hamid from eHealth New South Wales to talk about their story in building capability to support their organization and their mission. We'll look at the technical solution, and then we'll leave you with a few takeaways to learn more and get started yourselves. As you probably heard several times over the last couple of days, AI and the transformative power of it has the potential to reshape every industry. It will transform every aspect of how we operate as organizations and individuals. Similarly, in healthcare, we're seeing customers reinventing how care is delivered, from enhancing patient and clinician engagement, to reinventing, to automation for everyday tasks, and surfacing insights to support decision-making, with the ultimate goal to drive better care and outcomes for patients and providers. However, at the core of any successful AI application or use case is your organization's data. As it was before this explosion in generative AI, your data continues to be a strategic asset for every organization and yourselves, and perhaps even more so today than before. Your data in your core databases and your data lakes is your differentiator to fine-tune and contextualize the latest AI models for your specific use case. For those of you who work in healthcare, it'll come as no surprise, and I'm sure you'll all agree, one thing healthcare doesn't have a lack of is data. But it's not, the challenge isn't collecting this data, the challenge is managing and driving value from this data. Patients today are generating thousands of data points throughout their journey, throughout the healthcare journey and patient journey. But as a recent Accenture study indicated, only about a third of organizations are able to realize value from this data. And one of the key challenges in this space is data security and data governance. Data governance is a key and important component of being data-driven. But many times, data governance is treated as bureaucracy or something that slows an organization down. Don't get me wrong, every organization cares about their data, the security, governance, and privacy associated with it. But an area where we see customers and companies struggle often is building and defining a data governance model that doesn't become a bottleneck to innovation. Agility or governance is a false choice. The right style of governance with the right supporting tools for IT teams, data producers, and data consumers can both support innovation and give you the controls that you need. Every customer we speak to wants to be data-driven. They want to enable self-service analytics and machine learning. But being data-driven can be hard due to the disconnected data ecosystems organizations are having to deal with. If you look at some of the components of what it means to be to be data-driven and enable self-service analytics, a few things that shine through. First, you need an easy way to discover, understand, and access data across your organization. You then need to enable multiple people, like data analysts, data scientists, and data engineers to collaborate on the same data problem. All these different personas need access to different kinds of tools based on their requirements and skill sets, but be able to work in the same data consistently. Then you need a unified place for all these people in different teams and different skill sets to come together on their data journey. And lastly, and definitely not the least, you need a consistent but unique data governance model that works for your organization and your individual needs to ensure the security of this data. Now that we have an understanding of the potential for data, but also some of the challenges within it, I'd like to invite Hamid from eHealth New South Wales to talk to you about their work in building secure data environments on top of their data foundations, and hear how they're delivering or helping the New South Wales health system deliver on their mission for a patient-centered, efficient health experience. Over to you, Hamid.
Thanks, Matt. Thank you, On, and hello, everyone. Before we dive into our data landscape, our governance challenges, I really just want to give you a quick overview of New South Wales Health, especially in terms of the size and the scale. We are one of the largest, if not the largest, employer in the state, with more than 160,000 employees, serving more than 8 million residents of New South Wales. But what I really want to highlight is we are a very federated organization. We have 15 local health districts and 2 specialty network organizations. And each of these 17 health organizations are governed by a separate board. And they're led by a separate chief executive officer. What this means is that our data landscape is also quite federated and very, very diverse. Each of these chief executive officers are the data custodians for the clinical data residing in their respective clinical systems. To make the matters more complex from a data analytics standpoint, what's really the challenge here is that these data custodians are, because of the federated nature of the data, we have 9 clinical domains because of the way historically New South Wales Health has evolved. And what I mean by 9 clinical domains is we have 9 separate instances of electronic medical records. We have 9 separate instances of patient administration systems. And similarly, we have multiple instances of ICU systems, dental systems, maternity systems. You get the picture. The data landscape becomes really, really complex and very, very diverse to navigate. Now, if somebody wants to build a statewide data collection, historically, you had to write letters to each of these chief executive officers to really get approval to access their data. To make the matters even more complex, a lot of these electronic medical record systems and other peripheral systems are configured quite differently. So if you are, let's say, looking for systolic and diastolic blood pressure readings, it could be stored in table A in the first EMR instance. It could be stored in a completely separate table in the second EMR instance. If you add all these complexities together, it's easy to see why historically it has taken us up to 2 years just to build a simple statewide data collection. Now imagine if you're working on a new Premier's priority, and the starting point is to really get access to the data to really assemble a statewide data collection, only for you to realize that it'll take you 2 years just to even build a data collection, let alone completing the remaining steps in the data journey. Now this is a real blocker. And in order to solve this blocker, in order to remove this bottleneck, what we did is we basically centralized our entire organizational data in one place. So we took the data from most of our core clinical and corporate systems and put that into a central repository that we call the Enterprise Data Lake. What's really amazing about this data lake is Currently, it feeds data from more than 50 of our core clinical and corporate systems, and we do all of this in near real time. The other important aspect is we do this using very lightweight technologies so that it does not affect the performance of these live production systems. The other amazing feature about this data lake is that our customers or the consumers of the data lake have the ability to bring their own data into their private workspace. So they can subscribe to the key data assets which are already available, but they can also bring their own data and combine these data sets together to drive their use case. To give you an idea of the size and scale, we rolled out this solution in 2021. From there to today, this has grown to be about 500 terabytes in size, and we ingest approximately 700 gigabytes of change data every single day into this ecosystem. It's currently powering more than 100 parallel projects, doing all kinds of data analytics initiatives. For example, some people might be building a data mart, some people are building data warehouses, some people are building a training data set to train a machine learning model, and some people are driving large data migration projects off the back of this. So data lake solves one massive problem for us, and that is how do you easily get access to your organization's data? But it's not a silver bullet to solve all of our data analytics challenges. We still have one key issue, and that is the data governance. Now, as I mentioned earlier, due to the federated nature of New South Wales Health and having these different multiple data custodians, we really had to figure out a way on how do we streamline the data governance and the access problem. So we wrote letters to each of the chief executive officers of these health organizations, and we requested them to nominate peak data custodians to represent their local health district. The role of these peak data custodians is to basically provide advisory, and they advise these project owners or project users on how to navigate the complex data governance within their local health district. This way, we ensure that we are never making any assumptions in regards to the local processes in place within a local health district. We also requested the CEs to nominate data access controllers. Their main role is to approve access to a data set on behalf of the CEs if they're authorized to do so. The next step in the journey for us was to create a digital access workflow. This was to ensure that the data custodians always remain in control of their data, and they should have full visibility on who is using what data set, at what point they requested access to drive what use case, and for what duration they are going to have access to this data set. This is quite important for our data custodians. This gives us a full audit history and full audit trail. It's only at the point the data access controllers approve your access to the data, we provision a secure workspace containing only the data set that they are authorized to see. This ensures two things. The project users are only looking at the slice of data from this vast repository that they are interested in, and the second thing is it allows us to keep the cost really down. And they can do this subscription of data at the frequency that they desire. So if somebody wants a daily refresh or somebody wants an hourly refresh, that's absolutely possible using fully automated pipelines. So to summarize this, we've talked about two things so far. We have talked about how we are streamlining the access to data from our core and strategic operational systems. And the second part is how we are simplifying and streamlining our data governance. However, there is still a missing piece of the puzzle. Before I go into that missing piece, let me explain some of the use cases or the kinds of stories we hear from our different user personas. So over the years, a lot of data engineers would reach out to us and say, this is fantastic. You've given me access to the raw data. I can subscribe to anything I want with the right approvals in place. And I have the ability to break my own data set. But that's not where the story stops. That's where the journey actually begins. The journey from raw data to an actionable insight is quite long and tedious. Along the way, they need to curate these data sets. They need to sometimes build a curated data set to just build a data mart, for example, or maybe curate the data to train a machine learning algorithm. So what they need is a secure environment to go and do this. The other use case is a lot of the data scientists or ML engineers if they want to build let's say, a traditional data science model or a machine learning model, they need an environment where they have a notebook functionality to go maybe and write a Python code or an R code or maybe some other language code. And they need the full deployment capability for an ML use case. But the data custodians who are sitting over the top, providing the oversight and governance, they want to make sure it doesn't matter what your use case is. During this entire journey of raw data to actionable insight, they should have full oversight and full visibility of what's happening to their data, how it's being used. So they want to make sure that the data remains private and secure at all times, and there is not even an accidental risk of exposure of the data, especially the sensitive healthcare data. To solve this problem, we built data analytics platform. Let me explain what this is. The data analytics platform is a secure analytics platform where we have taken the cloud-native offerings from AWS, and these cloud-native offerings predominantly relate to data and analytics, and we have packaged them into a secure platform, and we have put lots of ring-fence that with a lot of guardrails around it. We have taken it through our internal privacy and security assurance framework process, but in addition to that, we've also put a lot of controls around it to ensure the security and the privacy of the data. At present, this particular platform is only available to our internal performance analytics team and internal researchers, research use cases, and the sensitive data never leaves the boundaries of the secure New South Wales Health Network. The way it behaves is it's like a secure pod. Every project can have their own secure pod where they can play with the sensitive data to deliver their end-to-end use case, and at the point of delivery of the output, they can either exfiltrate the data with the appropriate permissions from the data governance, the people who are controlling the data governance, these data custodians, or they can just simply decide to decommission the entire pod. We've also put a lot of controls in place to ensure that you can fully align your project with the 5 Safes framework and also the newly developed New South Wales AI Assurance Framework. When we set out to design this platform, these are some of the key design considerations we had in mind. The security of the health-sensitive data and preserving the privacy was absolutely at the forefront of our design. As I mentioned earlier, there are sufficient controls in place, and you can enable them as desired to ensure alignment with the 5 Safes framework and the AI assurance framework. The de-identification of data, particularly for 5 Safes alignment, is something you have to undertake separately. The other feature is that any code that you build, any data pipeline for data engineering or ML or any other use case, any code deployment pipeline happens using the modern CI/CD principles. So it's fully automated. Because it's built using the cloud-native technologies, you get the full benefit of the scalability and the elasticity of the cloud. We have built this with a shopping cart mindset where if you have 10 services available in this platform and your project only needs to use 2 of those, you can pick and choose the services that you wish to enable, and that allows you to keep the cost of the platform significantly down. And you only pay for what you're using. To ensure the reusability of the code and the assets you're building there, we have a Git Enterprise, which we call internally Git Health, an enterprise Git edition that's fully integrated with this platform. The other cool feature is you can actually bring your own code into this platform. So let's say you love some project in the open source community and you wish to deploy their ML or data engineering pipeline code to maybe convert a Cerner data into something more meaningful and actionable. You can bring that code, but it goes through a series of vulnerability scans and a series of checks and balances. And if you spot any vulnerabilities, it gets parked where you need to go and fix those vulnerabilities, but then you can ultimately deploy this within your secure pod and use it within your project. To summarize this all, these are the key capabilities that we have enabled. You have the full deployment functionality available within this platform for AI or machine learning use case. You have the automated code deployment functionality available. You can bring your own code. A lot of our users come from Microsoft technology stack background, and they wanted a virtual desktop, a Citrix-style interface, where they could run maybe their SaaS desktop or maybe an RStudio, for example. For that reason, we enable a virtual desktop functionality. We have multiple data transformation tools available within this platform, including a free version of dbt, which can be deployed on demand. We also have a BI tool available, so you can visualize the output of your data sets in the end. Let's look at some of the more recent use cases for Enterprise Data Lake and DAP. Sydney Local Health District is one of the biggest and the heaviest user of the Enterprise Data Lake and DAP today. They have deployed numerous use cases. One of those use cases relates to women and babies, and specifically relates to reducing the infant mortality rate. What they've observed across all of their use cases is that the time it takes for them to execute their queries, which they used to do on the live operational system, it used to take them 8 hours or more traditionally. That time was basically cut down to less than 30 seconds when they were running those same queries on this environment. The other thing is that the access to the data from their core EMR system and the surrounding peripheral systems is significantly more streamlined. They no longer have to worry about downloading the data into CSV files and plugging into a tool of their choice, because everything is just plug and play on this environment. Another use case is from the rapid surveillance team. This team is part of the Center of Epidemiology and Evidence-Based Research within Ministry of Health. They have developed a platform called as FREDS. What this platform does is basically collates data from the unplanned emergency department presentations and also collates data from the ambulance 000 emergency calls. It aggregates all the data together and it categorizes them into various acute illnesses and different injury types. And then they plot this over a time series and monitor this on a daily basis. And the main reason they do that is to ensure if there is a disease outbreak developing in any cluster, they can spot those anomalies pretty quickly. Or any other, I guess, scenario which could be a cause of concern for population health. They used to run their entire analytics engine, their ETL pipelines, everything on SaaS, using a very traditional file storage type architecture. After moving to a combination of EDL and data analytics platform, they have observed the storage cost actually came down significantly. The query response time, in some cases, they saw a 368-fold increase in the query response time, which is phenomenal. They also noticed their database cost has come down quite substantially after moving to these platforms. Another use case is a machine learning use case that was developed by Southern New South Wales LHD, and that relates to assessing the patient readmission risk, especially when you're discharging them. And what they did is they used a combination of SageMaker and Enterprise Data Lake to access their EMR data, and they developed the use case, and they also observed a similar performance and the efficiency gains and the productivity boost. What's common across, the common theme across all these use cases is that the time to value from raw data to delivering your outcome was brought down from multiple years to a matter of a few months. And that's really the key benefit. So what's next from here? We are working on the next version of our data analytics platform, and there are two key drivers for that. The first one is Ministry of Health have released a minimum set of guidelines for what a secure analytics platform should look like. We are ensuring the alignment with that. We are also looking at opening this next version for the external use cases, and the identity management, especially for the external users, is one of the key considerations for us, so we are evaluating options there. We're also enhancing our data governance, especially as it relates to the exfiltration of data and infiltration of data for external use cases. We're also looking at revisiting our network plumbing, and we're also looking at enabling this Amazon SageMaker Studio, and also we're consolidating all of our 9 clinical domains into a statewide domain, and Epic has been chosen as a tool of choice for that, and we're looking at integrating that data set also into the EDL and data analytics platform. With that, I will hand it over to On again, who will walk you through the DAP architecture in a bit more technical details. Thank you.
Thank you, Amit. Some great insights there, and it's really exciting to see the outcomes of these key use cases supported by the data platform. We'll dive a little bit deeper into the actual architecture and the solution components and services that enable the capability Hamid spoke about. Similar to all critical New South Wales Health workloads, the enterprise data lake is hosted within the AWS landing zone, which means that it inherits guardrails and controls which are applicable to the broader AWS organization. Hamid spoke to you about the data governance framework and the automation, the digital access automation that kicks in. Essentially, as part of that automation, a secure workspace is provisioned for the project, and by data sharing, the subset of the data for that project is made available in a secure workspace. The data platform is then enabled by an automated and administrative and provisioning process. That includes infrastructure as code, so essentially defining the infrastructure and the automation in code, pipelines to deploy that infrastructure, and then, as Hamid mentioned, Git Health, which enables the management of that code, but also then enables the bring your own code capability within the platform as well. The data analytics platform, or DAP accounts, are provisioned within a cluster within this landing zone, and which this allows for centralized monitoring capability. There then kicks in the automated pipeline that builds the environment for each project. So as access is granted via secure form, the DAP environment is provisioned. As that takes a number of automated steps that we will just quickly walk through. So the account is provisioned and it's bootstrapped to the landing zone, but at this point, specific guardrails are put in place to ensure the security of the data within this environment. Examples of this is there's no public access to the environment. It's only authorized users that can access it. Bringing data in and exfiltration of data is tightly controlled and restricted as required. The next step is secure access to the data lake workspace is provisioned to allow users to then access this data. Additional bootstrapping creates identity and an access management role to allow users to access the platform, security groups for network control, and infrastructure like S3 buckets to allow users to build data marts and offsets of their raw data in the platform as well. One key capability that Hamid talked about was the self-service catalog capability. Essentially, at this point, a service catalog of approved products are made available or shared within this environment for users to start to consume. And we'll go in a little bit detail into what these products are as well. Now that the environment is provisioned and ready for user access, authenticated and authorized users are provided access to the environment. They can get access to their authorized data, start to collaborate, and build their use cases out. As I mentioned, the approved service catalog of products enables the functionality within the platform. So as an example, virtual desktops are delivered through Amazon AppStream. SageMaker and Bedrock are used to deliver machine learning and generative AI tools. Data transformation is supported by open source dbt running on AWS Batch, and SQL analysis is enabled by Amazon Athena. There's several more products, up to 10 within the platform. The key thing here is these are not pre-provisioned. They're presented as a catalog for users to pick and choose which one they need for their use case, which allows control, hands back control to the users in terms of the tools they need, but also make sure that only services that are required are provisioned in the environment. So essentially, the DAP enables capability which allows environments to be provisioned in minutes through automation, self-service capability for users of the platform. The environment is isolated and self-contained, which makes security management really easy, both for administrators and data custodians in terms of visibility and management of how data moves, but also for users of the platform so they don't have to go through assurance and security checks before getting access to the data, because it's a secured environment that they're operating in. With this, I'd like you to think about how this can help you. AWS has a comprehensive set of integrated services which are suitable for any user, any data type, and which also has tools to allow you to govern that data. I encourage you to think about how you can leverage this to leverage these services and features to solve your mission. I'd like to leave you with a couple of resources to get you started. On the first link is to the eHealth New South Wales explainer on the Enterprise Data Lake. You'll learn more about what they're building. The second one is a product page for the Amazon SageMaker Next Generation. If you've looked at SageMaker before, I encourage you to look again. It's being developed as a tool to bring capability which is unified within AWS and brings together a lot of capability together. And for those of you who likes to get your hands-on tools and learn, the last one is a blog post which helps you through the administrative setup of SageMaker Unified Studio for that unified experience. Thanks so much for joining us today. Hope you enjoyed it and learned something new. Get onto the app, provide us your feedback. Thank you.
Awesome. Thank you so much, everyone.